In 11b, we want to do the same thing. We want to prove that f g of x returns a value of x. So I'm going to do f of g of x. Put that in first. So I'm going to do f of the square root of 5 minus x all over 3. And function f is negative 3x squared plus 5. And they have a restriction that x has to be greater than or equal to 0. So we'll have to make sure we're paying attention to that. So I'm going to put this into x. So g is going into function f, so it's a negative 3 times the square root of 5 minus x divided by 3 squared plus 5. And I want to make sure that that will return a value of x. So equals, we're going to square. Squaring a square root undoes it, so it's going to be negative 3 times 5 minus x all over 3 plus 5. I'm going to use my properties of fractions, and that means I can reduce common factors. 3 will go into 3, 1, so I'm left with a negative 1 times 5 minus x plus 5. That is a negative 5 plus x plus 5, and the negative 5 and 5 cancel, so we're left with x. Got it. Okay, so we know that those are inverses. Now we want to come back and we want to do g of f at x. Oh, I'm going to clean up the board here so I can have more room. So g of f at x equals, we want to put f in to function g. I wrote that wrong, so let me write it correctly. This is g of f of x. And that's putting f at x into function g. So that's putting a negative 3x squared plus 5. We're putting that into function g of x, which is 5 minus x over 3, which means this input is going in for the x right here. So it's going to be the square root of 5 minus, parenthesis, negative 3x squared plus 5 all over 3, and that's all underneath that radical. So what we're going to do is we're going to distribute our negative, so that's 5 plus 3x squared minus 5 all over 3. I'm going to keep simplifying underneath that radical, so it's going to be the square root of, the positive 5, negative 5 cancel, so it's going to be 3x squared divided by 3. Then we'll reduce the factors of 3, so that's going to be the square root of x squared, which is officially just x plus or minus x. I don't have to worry about too much of the other part because they're telling us from the very beginning that x has to be greater than or equal to 0. So that keeps this defined as long as x is greater than or equal to 0. So it returns an x value as well. So I have shown that both g undoes f and f undoes g, so they're inverse functions of each other. That is the nature of the show me's or the proofs on inverse functions.